Hey, this is Workbench or Workbench Quagmire, back with our free code camp Python certification in 100-ish days. Is day 93, and we're going to start our review for the final test exam. And if you look at the review, which I have up on my screen, you can't see, but you can look at it yourself. There's quite a few topics. This has taken us 93 days to get to here. So as you can imagine, we got a lot of stuff to cover here. Hope to cover this in about 7 videos and kind of refresh our memory of some of the stuff that we covered, especially, 80, 70, 50 days ago. So we're going to start at the very beginning here, and I'm not going to cover kind of some of this stuff. I have a file here with some stuff we're going to work through, kind of some examples, but it follows along with the Python review. So Python, what is Python? It's an introduction. The introduction, Python is a general purpose programming language known for its simplicity, ease of use, and Python is used in many fields like data science and machine learning, web development, scripting and automation, embedded systems, IoT, and much more. Common use cases are data science, machine learning, web development, microcomputers like Raspberry Pi and MicroPython compatible boards. You can figure out how to set it up yourself if you go to python.org and download it. And so we will start with the interactive portion of this with variables, declaring variables. We declare variables with the equals operator, the single equals operator, which is probably one of my most frequent issues is when I try to do comparison and I only use one operator, one equals. So to declare a variable, you start with a variable name followed by the assignment operator, the equals, and then the value. It can be a number, string, Boolean. We'll cover that. Here are some examples. So in my example, I have my name, or a name. That's not my name. John Doe. That's a string. So we're assigning the string John Doe to the variable name. We're assigning the string John Doe's garage to the variable name workplace. We're assigning the integer 25 to age. We're assigning the Boolean value to valid. And one of the things to note here is variables can only start with letters or underscores. They can only contain alphanumeric characters and underscores. So you can see here's a properly formatted Python variable name. It's called snake case, so it's all lowercase, and you separate the words with underscores. So variables are age or case sensitive also. So capital A, age, and capital all, capitalizing the entire word age, is different than lowercase age. And you cannot use Python keywords, so you can't call something like if equals 10. That will not work, and it should throw an error. Yep, there we go. Line 8, invalid syntax. So comments, single line comments start with a hash or a pound. You see comments down here. All this stuff is commented out. Comment. Multi-line comments, 3 double quotes followed by a comment, and then 3 double quotes. This is common for file header comments, class comments, things like that often show up in the help documentation. So the print function. To print data to the console, you use the print function like this. There we go. Print the name John Doe. John Doe's garage. Now on to common data types in Python. Python's dynamically typed language like JavaScript, meaning you don't need to explicitly declare types for variables. The language knows what type of a variable is based on what you assign to the variable. An integer is a whole number without decimals. So age is an integer. Float is a decimal number, so this float, we can't use float. I have violated the rules, and that's why it's highlighted. My float. There we go. A float is a decimal number. A string is a sequence of characters. So, sequence of characters, J is a character, O is a character. So, there are a sequence of characters. In other languages like C and Java has I think, a complex data type string. But like in C, there are no strings in C. There's character arrays. So, Booleans, true and false. So my underscore valid, which underscore valid is a valid variable name. Sets. A set is a non-repeating unordered collection, or an unordered collection of unique items. So none of these can be the same thing. If you put, for example, let's put 2 in here again, and then go to the next line and print my set. You can see that 2 only appears once. So it is unique items. So if you try to assign a non-unique item, it will not work. Dictionaries is a collection of key value pairs. So here we have the key name, the value, the string workbench, the key age, the integer 42. So you can mix these. The key has to be a non or an immutable type. So a string, and the other thing you could use as a key is a tuple. Tuples are immutable as well, which is the next item on my list here. Tuple, which is just an immutable ordered collection enclosed in parentheses. So the next item is a list. So this is basically an immutable list, sort of. So a list, we can change these items. A tuple, we cannot. Range is a sequence of numbers often used in a for loop. I don't have an example of a range in here. So my range, you have to use the range keyword, and it's 5. And if you print my range, you'll see that the 5 is not included. So range is from 0 to 5. But if you say, let's do a for loop. We haven't gotten to that yet, but so you can see there, my range is actually 0 through 4 because the 5 is not inclusive. So that's a range. The next item is a list. So this can be a collection. A list is an ordered collection of elements that supports different data types. So you see I got a string, an integer, a boolean, a tuple, because this is the variable name for a tuple, and then the last data type is a none. So a none is a special value that represents the absence of a value. So frequently you may set a variable to none before you do something, and then you check if it's still none. And so it may say, well, A equals none. If B is greater than 10, none equals true, or A equals true. And then you'd say, if A, so basically if it's true, If it's none, the loop won't run. There's all kinds of things you can do with none, and we did stuff with none within all of our little labs and workshops. So immutable, mutable data types. So immutable types, these cannot be changed once declared. Although you can point their variables at something new, which is called reassignment. They include integer, float, complex, Boolean, string, tuple, range, and none. Mutable, these types can be changed once declared. You can add, remove, and update their items. This includes collection types such as lists, sets, and dictionaries. The type function, you can see what type the variable is. So I think I have an example of that here. Let's comment this out. So the type of age is int. And the next thing is instance. We use this quite a bit throughout this certification. So we can see here type age is int, and then here we say is instance age int, and it says true. If we change this to string, you can see now it's false. Working with strings. If you know anything about JavaScript, strings are immutable, which means you cannot change them after they are created. In Python, you can either use single or double quotes to create a string. It's recommended to choose a rule and stick with it. I had somebody tell me one time, and I sort of try to follow this when I can, is to use a single quote because it doesn't require you to hit shift. It's one less key you have to press. So in this case, you can see here I've used single quotes on all of these, I think. Yeah. So, but if you have, like in this case here, where you have a single quote in it, you could use a double quote, or you can do what I did here and escape that single quote by putting a slash in front of it that tells Python, hey, print this character. This is not the end of the string. Accessing characters from a string. So we could actually, let's go down here and comment this stuff out again. So we have like this workplace. We can say, what is the actually fifth character? Because we're using 0 index here. And why didn't that print? Oh, because the fourth character is a space. So it did print. We just didn't see it. There you go. The sixth character is a D. So you can do that. We can also reverse index. So it's the last character is an E. You can do that -2, -3, however. Escaping a string, I showed that here. The slash, so you can escape the quotes. It's also, you can put like a new line character in here. And actually, oops. The new line character in, take our indexing out. Let's see here, John Doe's garage. We created a new line, just a blank line here, and then we print the next line. String concatenation, this is where you use the plus operator to put together multiple elements to create a string. In this case, we've used the name variable, which is a string, John Doe, plus this actual string that we inserted here, works at, plus the workplace of John Doe. And so that actually prints John Doe works at John Doe's garage. F strings is another way to use strings. So this is an F string. Again, you can use single or double quotes as long as it's consistent. You have to put the F in front of here. So this F string, you can use this outside of a print function. You most commonly kind of see them in returns and prints, but you could say my string equals, and then just put F and all the rest of this, and that will create the string. And then like if you change the name or age, like for instance in a loop, you could say my string, print my string each time, and each time if you change the name and age through the loop, that would change as well. So in this case, we say my name is, and then we use these curly brackets to put in the variables. You can do calculations in here. We could put in here 10 times 10. Then when we print, we get my name is John Doe, I'm 25 years old, 100. So it's pretty useful formatting for strings there. The old string formatting, some of the string formatting stuff can be kind of complicated, I think, but F strings are super awesome, and we got them in Python 3. I think like 3.6 or something like that. String slicing. So we saw the string index. The other thing we can do is string slicing. We'll go back up here, and so we can say :6, and this will give us the 0 through 5th character, since we don't put anything in front of the colon. Well, oh, we have not saved the file apparently. There we go. So John D, because we're going 0, 1, 2, 3, 4, 5, because the 6 is not inclusive. The other thing we can do here is you can start at 3 and go to the end. There we go. And you can also put in here -1. I believe this is the direction. Yep. So you can reverse it. So that prints every other character, or in this case, is it every third character? Yeah, it's every other character. J, H, space, O. So we could change that to a 3. It prints every third character. So string slicing is pretty handy. So up next, getting the length of a string. So that's something we can do. I have an example in here somewhere. Here we go. Like this. So this will give us the length of our name string, which is 8 characters. Using the len keyword for length. We can also do like a list length. So there's 6 elements in our list. The in operator. So here is an example of that. My list does have the number 42 in it, so I'm going to print 42 in my list, and it'll return a Boolean if it's true, which it should. And if we change this to something that's not in the list, like IN, it's false. So that's a very common thing when you're doing conditionals, like if statements. You say in the list, and then if it's true, then you go to the next line, you run that command, run that out. And now we're to common string operators. So we've got uppercase, strip, split, join, starts with, find, count. Then we got a new string here. And then we don't do trans table yet. So we have name upper, cleaned. So this upper, it's going to be kind of messy. Oh, join is never closed. So we can see here, name dot upper makes John Doe all uppercase. You can do the same thing with lower. If you put lower in there, I'll take out the capital J and the capital D in name. The next one is strip. So we have this string clean that has 2 underscores in front and 2 underscores in back, and we say we want to strip the underscores. And so you can see here, cleaned has no underscores once it's printed. The split string method, take this string and then we're going to split it on the dashes, so it gives us a list of strings now. And then we can take that list if we wanted to. We got a different list here, but we could join it together with something. In this case, we're using a space. So it ends up giving us Workbench is having a great day with spaces between all the words. The next item, oops, we forgot replace. Print name dot replace, and then take something, say the John, we replace it with Joe. Oh, we're gonna need another. So now we have Joe Doe. If we use the replace method, we have the starts with, which basically just looks for work and Workbench. You can see here under the Joe Doe, we get true, that we found that. If we don't find it, So now it's false because we don't find fork. Or it doesn't start with fork. The next item is fine. So then we say name find W. And it says, well, there's no W in there, so it returns a -1. If we change that to the J, actually replace it, we'll look for D. So now it's going to give us 5 instead of a -1 because it can find the D. It's the 5th character. So we also have the count method, which will count, in this case, the number of dashes. And there are 3 dashes in that string. Then we have this new string that I created here. And then we want a new string capitalize. Capitalizes the first character. Is lower, checks to see if all the characters are lower, and it's true. Is upper, checks to see if all characters are upper, it's false. Title actually makes the first character capitalized. And that is our string methods. Ends with finds, count, capitalize, is upper, is lower, title, and then we have this Then we have this translation functionality for Python strings. So we can create a translation table, in this case trans table. It's a string method, so string.makeTrans, and we give it a string that's basically the characters we want to translate, ABC, and what we want them to translate it into is another string. This is a numbers, right? But they're in quotes, so they're a string. And then down here we have this results. So we take the string ABC, ABC, and we use the translate function and give it the translate table, and then we get a result. So you see the translate table actually is giving us, I believe, the Unicode numbers. And it's saying, okay, 97 is now 49. 98 is now 50. 99 is now 51. And then you can see our result here is 123, 123. So that's all I'm going to cover for today. That's our first review session for our exam coming up. Thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time with more review for our Python certification exam.